Alright, I'm going to go over the second problem that I gave you guys. It says write the equation of a sine curve with all this other stuff. And so it's pretty straightforward. It's y equals, and then it's the sine of something. Okay, so let's just go through. The amplitude is 3, so that's the number in front of the sine. The axis of wave is 12, so that goes out front. The period is 365. So in order to make that work, the number here should be 2 pi over 365. And then it's got a phase shift of 80 to the right. So that's x minus 80 right there. Remember that this number right here is 2 pi over b is the period. And so this number is b right here. So if you substitute that in here, you'll see that that gives you 365 as that period. So that's why we have that. Okay, so I'm going to make a quick sketch of this graph. And I've sort of started it. I've got y equals 12 here. The amplitude is 3. So we're going up to 15 and down to 9. I've got the axis of wave sort of already there. And it says a phase shift of 80 to the right. So a sine curve starts in the middle. So if I'm drawing this, it's going to start right there. Okay? And I'm going to break that. This is like 80 plus 365, which is 445. But I don't really care. I'm just going to break that up into quarters and graph it. So sine starts in the middle and goes up. So it's going to be here, then back to the middle, then at the bottom, then back to the middle. Okay, and so here's your graph. Okay. All right, so we move on to the next problem. It says in Chicago, the average number of hours of sunlight is 12. At the start of summer, there are 15 hours of daylight, and as winter starts, there's 9 hours. The vernal equinox, that's the first day of spring, by the way. That's when the amount of hours of daylight and non-daylight are the same. It says write an equation representing the number of hours of sunlight on the xth day of the year. So that's kind of a weird situation to draw or to write a trig function about. So maybe some of these numbers showed up in the problem before. For instance, I know there's 365 days in a year. And I know that the average is 12. That was in the problem before. The most sunlight a day would have is 15 hours, and the least is 9. That appeared to be in the problem. So from 15 we can go up 3 or down 3. The 80th day of the year, well, the problem before had a phase shift of 80. So I wonder if what we did before has something to do with this. Let me go back up there, and let's think about it. So it's on the 80th day of the year, that's March 21st, there's 12 hours of sunlight. Well, that's this point right here. Okay, and when March 21st hits, days continue to get longer until they reach the longest day of the year, which is the first day of the summer. That's roughly a quarter of a year. That's how long a season is. And then once the first day of summer hits, we see that days start getting shorter until the first day of fall. This is the first day of fall right here. And then they continue to get shorter. We're in that time period right now where it's getting darker earlier and every day until we get to the first day of winter. That would be December 21st, roughly. And at that point, days start getting longer. But the first day of winter is the shortest day of the year, and it's 9 hours, roughly, in Chicago. And then so we go up like this. So actually, the equation that we wrote right here could be a model that tells us how many hours of sunlight there are on a specific day of the year, which is really interesting that that would be modeled with a trigonometric function like sine. Okay? Pretty interesting.